So the second part has to do with arcs and chords. When you guys, if you take your ACT test next year, which I'm guessing quite a few of you will, a lot of the ACT test is geometry stuff. They have a decent amount of this circle stuff we're going to cover in chapter 10 on the ACT. I would say it's close to half the stuff that's on that is from geometry. Central angle. It's kind of what it just sounds like. In a circle, you have a center, right? If you draw two radiuses or two radii, what does it form? An angle that's in the center. So this is a central angle. It's just the vertex is the center. Okay? Next section, it's not this section, no. Next section, we have another type of angle where it's made up of two chords, like this. That's called an inscribed angle. So you need to know the difference between central angle and inscribed angle. All right? Now, here's what's going to happen. I'm just going to show it to you now so you see more of it. This angle intersects the circle there and there, right? This one intersects there and there. How many degrees in a circle? 360. And you can also measure how far around the circle is, right? So there's 360 degrees here, but this angle intersects this portion of the circle. So if this was 75 degrees of the whole circle, this angle would also be 75 degrees. The central angle and the arc it intersects will always be the same degrees. On an inscribed angle, it's a little different. This one, this arc right here is almost, I'd say that's about 100 degrees right there of the whole circle. This angle here is obviously not 100 because it's less than 90. So if you had to guess what it is, it's half. It's 50. An inscribed angle is half of the arc. Its central angle is the same as the arc. So again, all we're doing today is the central angles, not the inscribed, so don't need to worry about that yet. But. Okay, arcs. In a circle, if I had these 3 points, if I talked about arc AB, that is just, it would be labeled like that. Arcs have just an arc above them. And it doesn't matter which way you put it, just like a segment. A, B, B, A, it's the same. A minor arc is less than 180. So a major arc would be more than 180. Any guess what a semicircle is? 180. So when you name minor arcs, they only use 2 letters. Because someone says, well, how do you know they're not talking about going this way? Because this would be arc AB also. But when they use 2 letters, that means take the shortest route. All right? So if they talk about arc BC, that doesn't mean to go this way. It would mean to go this way because it's shorter this way. Okay? When they talk about a major arc, they use 3 letters. So if I'm talking about this arc right here, I can't just call it AC because that means take the shortest route. So what they do is they call it arc ABC, or you could call it CBA. Okay? So major arcs have 3 letters, minor arcs have 2 letters. And then a semicircle is just if you got a diameter then. Okay, so it doesn't matter which way you go here, AB. If I go this way, it's 180. If I go this way, it's 180, right? Okay. So when I talked about measures of these arcs, it's just remember it's 360 degrees around any circle. And so if I measured this arc, it's just what fraction. So if this was a 80-degree angle right here, the measure of this arc would be 80, because central angles and arcs are the same. Congruent arcs are just what they sound like, equal arcs. Now, this one goes back to like the very first week of school. We had the segment addition postulate, and then we had angle addition postulate later. It's just the common sense. They're just saying if you take arc AC and add on arc CB, what do you have? Arc ACB. That's all it means. If you add this arc to that arc, you've got a bigger arc. So that's the same thing as the segment addition was. If you take a little segment and add on another segment, you've got a bigger segment, right? The angle addition was if you take one angle and add another angle onto it, you've got a bigger angle. So that's nothing we really need to know. That's just common sense. But when you do proofs, you need to put that kind of stuff in there. So here's what we'll be doing. You'll have a picture, and then you just got to answer what the measure of these arcs are. So the best thing to do is to find all the missing. Now remember vertical angles, they have these a lot. There are no vertical angles here because these are not vertical, right? Because it's not a straight line, and these are not vertical because it's not.
Is that just how you tell as if it's a straight line?
Yep, vertical angles would be like this. This one, and that one, and that one. Two straight lines. So what we can do here is we can figure out there's only one angle missing right here. Does everyone know how you would figure out what it is? Subtract them from 360. Take these three away from 360. And it is 90, yep. So now to answer the questions, arc DG, since it's two letters, you take the shortest route. So that'd be there. 70 and 80 is 150. DGF means you start at D, go through G, and end at F. So that means I gotta go this way. So that's everything but the 80. So that would be 280. 360 minus 80. And then DH means start at D and go to H. The shortest way you can is 90. Okay, easy enough?
Yes.
All right, here we've got some theorems. Now, some of these are so simple, like once I go through, I'll show you the types of problems they're going to have. This says if you got a circle that have two congruent arcs, two congruent chords. If these two chords are equal, then these two arcs are going to be equal. Okay? So if the chords are equal, the arcs are equal. And then that works backwards too. If the arcs are equal, then the chords are equal. All right. Then on this one, if the diameter of a circle is perpendicular to a chord, then the diameter bisects that chord. Okay? So if you see a picture like this, you would know then, like here's an example of a problem you'll have today. If this is 6, they'll ask you what's ED. It's 6. Okay? So it's that simple. This one goes along with it. If one chord is the perpendicular bisector of another chord, then this has to be a diameter. See, they don't have the center here? But if it bisects and it's perpendicular, then you know that that's a diameter. And then this last one is if you've got two chords that are congruent, that means the distance to them are the same. so this would equal that. So if these two chords are equal to each other, you know then that if this is 5, this is also 5. Alright? Make sense? Now, using these, I think there's a problem like this in your book, but this stuff up here is how they used to. I'd imagine that it's better technology now. But when people get caught in avalanches, when they go skiing in these dangerous mountains, they used to have to carry a locator or whatever. So if they got buried, the people would come and try and dig them out, right? But they got to find them first. So this is what it used to be. Like I said, I'm sure it's more advanced now, but what they would do is they would have people just walking around trying to pick up this signal, and the person's signal would put out a beep of a certain radius. So they would have to walk into this circle. We'll just say the person's here, and the beep is going out like that. So the people would be walking around, and their thing wouldn't go off until they got into the circle. So say they're walking like this, and it starts going off here. That means it can be anywhere, right? They don't know what to do, but they know they've hit the edge of a circle, so they put a flag down, and then they keep walking until it quits beeping, and then they put a flag, because then they know they hit the other edge of the circle. So they know they found a chord, and then what they do is they go back to the center of this, and they walk at a 90 until it beeps again. So they know they're on that. So they know this is the diameter then, because it's perpendicular and it's bisected from these. So then they just walk back through until it beeps again, and they put a flag, and they know the person is in the center of that.
That's cool.
Yeah. They might be dead by then, but they were probably dead already. Maybe not.
Well, at least they found the body.
Right. But like I said, I'm sure, I would guess they have better technology today. So, these problems, they look complicated, but they're really not. If this is perpendicular, you know that this is bisected, so this equals that. And if the chords equal each other, what do you know about the arcs?
The arcs would be cool.
So that means 5x has to equal, right. So subtract 7x, 2x, negative 2x equals negative 16, divide by negative 2, and you get 8. This one again, since this is perpendicular, I know that this and this, well, I better look up here first. MN is 16, right here. So that means since it's perpendicular, that's 8 and that's 8. And RT is also 16, so that's 8 and that's 8. Now, they're wondering how long is QS right there. Well, remember, if you find this, it'll be the same, right? So, right there, what's that? A right triangle.
10 plus 8 squared.
Minus, because it's the hypotenuse. You gotta use the Pythagorean theorem. 10 squared minus 8 squared, square root it, is 6. It's a 6, 8, 10.
How do you get the age on the top? How do you get
Here,
the age?
because they told us here that they were both 16.
Oh,
And since it's perpendicular, that means it's bisected, so that means it'd be 8 and 8. Okay, so on these, if the chords are equal like that, the arcs are equal, so it's just 7x equals 3x plus 24. And now I just want to point out, some of these are so easy. Sometimes I'll just go like this. This is x degrees, and this is 20 degrees, and they ask for what's x's. It's just 20, they're the same. Okay? But this one, you just set them equal to each other and solve it. Here you do got to use the Pythagorean theorem. They're looking for HK, which is going to be the same as this. DG and JL are both 24, which means they're equal. And since this is 90, that means it's 12 and 12. And they tell us that DH, which is a radius, is 13. So you got this right triangle, 13 squared minus 12 squared, square rooted. Anyone remember what that is?
Equal about
4 minus 25.
5.